Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
As present on your screen, there is a reaction which is unbalanced, and we are doing the balancing the redox reaction in basic medium. So the first of all, the thing that we should notice is whether the reaction is balanced or not in case of other elements rather than hydrogen and oxygen. So in this case, we could see that the oxygen is not balanced. That's fine, because there is a step where we could balance it. This tellurium is one times present on the reactant side, again it is present one times on the product side, again it is balanced. But when I talk about chlorine molecule or chlorine atom, in this case the chlorine atoms are 2, while in this case the chlorine atom is 1. So I could balance it here itself also. So this is how can we balance the reaction. So what I'll do is, I'll write the step number 1 as balancing chlorine atom. So in this case, the above equation will be now turned into this one. So now we can balance the overall reaction by taking the help of oxidation number method. So the first one is tellurium, which oxidation number is not known to us. So I would write the step number 2 as the rule that we have followed earlier also, that is determination of oxidation number. So I'll take it an example of the first reactant, that is tellurium trioxide. So therefore, for TeO2 minus, I could find out the oxidation number as, since tellurium is present one times in the reactant side, so T into 1 plus oxygen, which is present 3 times, so 3 into oxy, and the overall charge is -2. So therefore I would consider the oxidation number of tellurium as X plus 3 into the oxidation number of oxygen is -2, which will give us the answer as 4. So ultimately I could write the conclusion that the oxidation number of tellurium atom in TeO3 2 minus is 4 plus. Now moving towards the next one, that is for the next reactant, in this case chlorine molecule. So for that I could write it as the oxidation number of chlorine in Cl2 is, as we can see, there is no charge present on Cl2, so therefore it will be 0 itself. So moving towards the product one, the product is found to be tellurium tetroxide. So in this case I would consider, or I would write directly as 1 into tellurium plus 4 into oxy, which will give an overall oxidation number as -2. Therefore I would consider the oxidation number of tellurium as X plus 4 into -2, which will give an answer of 6. So in this case I would write the conclusion as the oxidation number of tellurium in TeO4 2 minus is 6 plus. And ultimately, when I talk about the chlorine atom or the chlorine ion which is present on the product side, so for Cl minus, it has been clearly mentioned that the oxidation number of Cl atom in this case is 1 minus. So by this thing, I have eventually determined what would be the oxidation number of the atoms which are present in the molecule. So let us see whether the reaction is a redox reaction or not. So for that, I could write the given equation as it is. That is so the oxidation number of tellurium for TO3 2 minus was found to be 4 plus, while that of chlorine or chlorine atom was found to be 0, while in this case it was found to be 6 plus, and while this case it was found to be 1 minus. So let us compare with tellurium itself and the chlorine atom with the chlorine atom, the oxidation number. So in this case, as we can see, the tellurium is converting from plus 4 to plus 6. It means it has lost electron. So by losing 2 electrons, it will convert from plus 4 oxidation state to plus 6 oxidation state. So therefore this process is nothing but oxidation. But when I observe the oxidation number of Cl, which is converting from 0 to 1 minus, as you can see, so this will be only possible if it takes 1 electron, and if it takes 1 electron, it means the gain of electron has been happened, and the gain of electron is nothing but reduction. So this is how we have confirmed that the given reaction is a redox reaction. But this is not over yet. Yes, we have to do the step number 2 also. So let's move towards the step next. The step number 3 would be, yes, balancing electron. So as we know that in oxidation the number of electrons are being lost, and in reduction the number of electrons are being gained. So for this case, the number of electron lost during oxidation, while the number of electron gained during reduction. So if we compare with the earlier equation that we have balanced, or we have determined the oxidation number, so we could get that the oxidation number of tellurium is changing, or in case of oxidation it is changing from plus 4 to plus 6. So from plus 4 to plus 6 it has been converting, so the number of electrons that could be lost in this case would be, yes, 2. While in case of conversion of 0 oxidation state to minus 1, the number of electrons that have been gained is 1. So therefore I could write it as, for oxidation the number of electron lost is 2, and for reduction in this process or in this equation the number of electrons are being gained is 1 during reduction. So as we can clearly observe that the number of electron lost and the number of electrons gained during the overall process is not being balanced. So we have to balance it by cross multiplication. So the first thing that we could do is, if I multiply the reduction value by 2, then the electrons will also balance each other. So in this case, what I am going to do is, I am going to multiply the reactants which is showing a reduction process by 2. Then only the electron will be balanced. So therefore, for that case, what I am going to do is, I am referring this equation and I'm going to multiply 2 by the one who is showing reduction, because I have mentioned here 2 which is multiplied by the reduction process. So this will be multiplied by 2, this reactant. So ultimately I'll get an answer as tellurium O3 2 minus plus 2 times of Cl2, that should give me tellurium O4 2 minus plus 2 into 2 which was now being 4 times Cl minus. So this is how I have balanced the electrons. Now moving to the next step, that is for balancing oxygen atoms. So the step number 4 will be balancing oxygen atoms. So in this case, let us see what would be the number of oxygen atom on left hand side and what would be the number of oxygen atom on right hand side. So let us compare. If we compare the oxidation, the number of oxygen on left hand side, that is on reactant side, it is found to be 3, while in case of the product it is found to be 4. So therefore on left hand side it is 3, while on right hand side it is 4. So the thing that we are going to do is we are going to find where is the deficiency and of how much. So the deficiency is found to be on left hand side. That is, one oxygen atom is less on the left hand side, that is on reactant side. So in this case we are going to add one H2 molecule on left hand side. So therefore adding 1 mole of H2O on left hand side, we get the equation which was found to be this one will be as it is, but there will be a difference that I will multiply 1 times H2O on the left hand side, or I will add 1 times H2O on the left hand side. So therefore TO thrice 2 minus plus 2 times Cl2 plus 1 times H2O, which will give me an answer of and the next step is balancing hydrogen. So let us do that also. So the step number 5 will be balancing hydrogen atoms. So for the left hand side, the number of hydrogen on left hand side will be so if we have observed the number of hydrogen on left hand side, it was found to be 2, while that on the right hand side it was found to be 0. So there is a deficiency of hydrogen on right hand side. So what we are going to do is we are going to add 2 times of H plus on right hand side. So therefore by adding 2 times of H plus on right hand side, we get an equation of O3 2 minus plus 2 times Cl2 plus H2O, that will give me an ultimate answer as TeO4 2 minus plus 4 times Cl minus plus, since we have instructed as we are adding 2 times of H plus ion, so we are adding 2 times of H plus ion on the right hand side. But this is not over yet, because this will give an solution which is present in acidic medium, but we are balancing it in basic medium. So the first of all, the thing that we should consider is we should neutralize this acidic solution. So therefore we will add the number of same OH minus ion which is present in acidic medium. So in this case the 2 times H plus is present in acidic medium, so we'll add 2 times of OH minus ion, but on both the side. So therefore, adding 2 times OH minus ion on both the side, we get an ultimate answer as TeO3 twice plus 2 times Cl2 plus H2O plus 2 times OH minus will give us an answer of TeO4 2 minus plus 4 times Cl minus plus 2 times 2H plus, which was already there, and we have added 2 times of OH minus again on both the side. So in this case, this H2 molecules which is present over here, that is 2 moles of H2O molecule, will be cancelled out by this H2O molecule. So ultimately the thing that is left with us is 1 times of H2O on right hand side. So ultimately the answer would be tellurium O3 2 minus plus 2 times Cl2 plus 2 times OH minus will ultimately give us an answer of TeO4 2 minus plus 4 times Cl minus plus H2O. So this is the final equation that we have balanced in the overall process. It was very much simple but a bit extra step too. So thank you friends for watching this video. I hope you have liked this video and you have got an idea that how to solve this kind of unbalanced equation by using this kind of method. So thank you friends, and share this video with your friends, and don't forget to subscribe Ekeeda channel. Thank you.